Hey everyone, in this part of the lesson on antiderivative rules, indefinite and definite integrals, we want to focus on this first success criteria to be successful for this learning target. And it's that when we're trying to evaluate indefinite integrals, so like something like this, there is this constant of integration, this plus c, which we're going to talk about what that means in the next part. All right, so here is an indefinite integral example. What is the indefinite integral of 2x dx? Now, to recall, what the indefinite integral essentially means is if we're given a function 2x, it's saying what was the original function, I'll call it capital F of x, original capital F of x. This is what we call the antiderivative function. Because, right, if little f is like the derivative function, capital F would be the original. That's just the notation we use. It's wondering what is the original function. So now to help us think about that, we just need to reverse our thinking, right? We just go, okay, well, we know the derivative of something is equal to 2x. So what must that something be? Well, we can go, oh, it must be like an x squared function, right? Because the derivative of x squared is 2x, right? The derivative of x squared equals 2x. So check, check. That makes sense. The original function must be x squared. Well, we are very close. So check this out. Take a look at this graph here. We have three functions, x squared plus 3, x squared, and x squared minus 2. Notice that they're all the same parabola, right? X squared, except we just shifted it up 3 and shifted it down 2. So we have three functions, parabolas, x squared parabolas. Okay, so now let's say we took the derivative of each one of these. What would you get? Well, the derivative of x squared plus 3 would be 2x, right? And the derivative of x squared would also be 2x. And the derivative of x squared minus 2 is also 2x. So remember over here, we said the answer is x squared, but that's not entirely true because the answer could be x squared plus 3. It could be x squared. It could be x squared minus 2. And it could be x squared minus pi. It could be x squared plus 1056.275. Right? There's an infinite amount of original functions that it could be. So what we do is we say, well, all of these x squareds are in common, right? So that's why we have the x squared. But we can add 3, subtract 2, minus pi, add the number. So we can say, in the end, we're just going to add some kind of constant or subtract a constant, but either way, it's the same thing. So we say, well, it can be x squared plus c, where this can represent any constant or any number, right? So we say x squared plus c to represent that. And this c right here, this c is what we call the constant of integration. All right, so let's summarize in some clean notes. So if we have an indefinite integral, so indefinite integral of some function f of x that's given to us. In our case, we were given 2x. Okay, so some function. And we know that there's no bounds because indefinite integrals don't have any bounds upper or lower limits. Okay, so if we have an indefinite integral, we know that this is equal to the antiderivative function capital F of x, right? This antiderivative function is the original function here, but we need to add c, where c is the constant of integration, because we know that the original function can be any number of these, like for example x squareds with a plus 3, minus 2, on and on and on. Okay, and so we can say this is the notation where, and let's just define what capital F of x is. Capital F of x is the antiderivative function of the given lowercase f of x. So in other words, we can say that the derivative of the capital F of x, the antiderivative, is the original f of x. All right, so let's just do a quick example. So, or practice, I should say. Okay, what would the answer to this be? Well, we know that this is like the original, or sorry, the derivative function. So the antiderivative function, or the original function, would be x cubed plus 2x. And I know that because the derivative of x cubed gives me 3x squared, and the derivative of 2x gives me 2, right? But I need to add a plus c because let's say c was like 1, 2, 3, or 4, or 5. We know when we take the derivative of a number, we just get 0 and hence get that derivative function. So this is the answer if you were ever asked to find the indefinite integral of 3x squared plus 2. All right, so conceptually, we now know how to find the indefinite integrals. So if we're given a 2x plus 3, we know that the original the antiderivative function is x squared plus 3x plus this c, or what we call the constant of integration. And we now know that the c represents any number, right? It can be like 1, 2, 3, 4, or 5, because when you take the derivative of a number, you just end up with 2x plus 3. So this is a very basic indefinite integral, right? So in this lesson, we're going to be doing more complex indefinite integrals and trying to find the original or the antiderivative function for more complex things like for polynomials, radicals, and all this stuff. So we're going to need to, in the next part, find the antiderivative rules to be able to evaluate these more challenging indefinite integrals.